Hello guys and welcome back. So now I have the sim here that I've previously generated, and you can completely ignore the sim. Think of this as a standalone, a still volume that we want to add details to. Forget that it's a sim or anything like that. It's just a volume that I've created in SOPs. So I'm gonna increase the density just in the viewport, and then I want to increase the resolution to show you guys how much details we have. Now this is a high-res sim that I actually simmed with the same techniques that we're going to be creating, but I'm going to blur it to lose all the details, and I'm gonna use a VDB smooth, and let's take a look. Let's increase that even more. I think this is good. Let's try 10. Let's try 4. Let's change it to Gaussian. Okay, this is good. Let's reduce this to 2. Okay, something like that. And you can see now we don't have any details. It's just a smooth volume. And with volume, we talked about something called gradient last time. And what the gradient is basically a normal for the volume. Imagine this is, let me convert this into a mesh. And let's find the value. So think of the gradient as a normal from the geometry that we can create from if we convert the volume into a mesh. And this guy has, let me create actually the normals. So we have normals here, and you can see they're pointing in the right direction following the curvature of the volume. So what we can do is we can take that direction and use it to displace the volume. We can compute the gradient, which is this, and use that to push the voxels along this vector and in the inverse direction to create a more interesting displacement that does not destroy the shape of the volume itself. It keeps it but adds details to it. It's very similar to adding displacement to a surface. So we can take this and actually let's use a peak node. And with the peak node, it can move the surface along its normal. We're going to do the same thing with the volume. So let's see how we can do that. So this is our original volume. First thing we need to compute this gradient, and we're going to use a VDB analysis node, and then we're going to tell it to the field that we want to compute the gradient for is called density, and then I'm gonna say custom name and call it grad, and this will make the result here, and you can see it's a vector field. Okay, now let me create a scatter node, and I want to show you what that data looks like. So let's scatter a bunch of points in this volume. Okay, let's do more. Okay, and let's do a volume VOT. A point VOT, because we want to operate on the points. And then let's connect this guy, and let's dive inside. And now we need a volume sample vector, because that's the type of the field we want to sample. And then let's connect that to the color. Okay, and the field we're interested in comes from the second input, and its name is called grad, just to be sure. Cool. So this is you can see it's basically a normal field. Now let's connect this to the normals of the points and take a look at that. Let me normalize them here. I think we have a lot of points. That's why the viewport is lagging. Okay, so you can see how it's following the curvature of the volume, sorry. Cool. So the next thing I want to do is I want to make a new field, and I'm gonna call it color. And the easiest way to do this is to take an existing field and just rename it. In this case, this is a vector field, so I'm going to rename it to color. And existing name is grad. I'm gonna rename grad to color. Okay, and if I merge all these guys now, this and this and this, I can create a volume with these three fields. It will have the density, the grad, and the color. And we want to create something in the color feed, so I'm going to create a volume VOP, and we're going to dive inside. Now, one difference is with points. Let me create a grid, a scatter node, and a point VOP. One difference between the volumes and the points is when you create a bind export node and say this is a test attribute, and you give it any value you want, say P, and then you go up. If you middle click, you will see test attribute getting added. This is not the case with the volumes. When you go inside the volume VOP and do a bind export and say test, and it's a float, if you go up, it's not going to create the field. You'll have to always predefine them. You'll have to always have them ready to be processed. And once they are existing, you can bind them in and bind export them back to change their values. Cool. So let's import that gradient. Okay. And then let me create a bind export, and I want to export that as the color, and it's 3 floats, and this guy is the 3 float as well. Okay, and what I'm going to do is I'm going to use a noise, an anti-alias noise, and use the gradient, use that normal to be the position of the noise. Okay, and I'm going to export that, and let's change this to 3D noise. And let's go back, and I want to sample that color now. I want to view it on these points. I can do it on the volume, but I want to use this for visualization all the time. So we have 1. Let's increase this to 3 to add more points. And let's see, we have, it's called color. Okay, and let's sample that, and let's export it to the color. Okay. We are getting some noise pattern. Cool. So let's tweak this a bit more. Let's increase the amplitude so we can see it. Okay, cool. And we're getting an interesting noise. Now let's reduce this base relative, and let's lower the frequency to see the details, to see bigger details. Cool. So you can see now we're generating a noise pattern that uses the normals, the gradient of this density field. And this is very, very interesting, because what's going to happen is when this volume moves, if it's a sim, when this block here is going to move, it's not going to move in a crazy way. It's going to move in a natural way. And every frame, we're going to be computing the gradient. So let's say in this frame here, the gradient is pointing this way. Actually, I think it's much better if I draw this. So let's say this is the mushroom shape, and we computed the gradient, which is this guy. And we have a perfect normal. The next frame, when this is going through the sim, it's not gonna just do this, for example. It's gonna do something natural. So it'll probably be something like this, okay? And obviously not quickly like this, but the normal, this guy will be reoriented to be pointing in this direction. This guy will be reoriented to this direction. This will move, and they're all sliding accordingly. They're not changing in any drastic way. They're all sliding and following the curvature of the mesh, and this is primarily the biggest limitation that Houdini has by default. This way we can use this information to generate a noise that follows the surface of our sim. It doesn't destroy it. It's not coming from an external place being applied onto. It's coming from within the volume itself. So if we use this gradient, which is basically an XYZ coordinate, it's a 3D, it's a 3 float, and the noise doesn't really care. We don't need to use the point position to generate a noise. We can use any vector, okay? And in this case, we're going to use the gradient. And by doing that, now if let me run a few frames, just maybe 56. And by the way, the black areas are actually filled with information. They're just negative. We cannot display them because this guy returns between -1 and 1. We can compute the absolute value to put them back in the positive range, but it's not a problem. That's useful information in there. And what's going to happen, what we're going to be doing is we're going to generate a noise, okay, based on this axis. And then we're going to use that noise to displace the volume. So this guy, for example, let's say we have this, we know it's normals, okay? We're going to push the sampling position along the gradient, okay? And that will give us this. We can push it like a surface, basically. And then we're going to multiply that displacement vector, that gradient, using the noise that we're going to create. So we're going to change it to look more interesting. Okay, it's going to push in and push out the volume, and all of that is going to follow through the curvature of the mesh. Now let me play this. You can see it's not jumping. It's following the curvature of the mesh. It's very stable. Now the use of the noise pattern is very interesting as well. But let me continue. Let me explain this further first and show how we're going to do the displacement, and then we'll talk about the noise patterns that are available for us to use. Okay, so we have the noise pattern, we have the gradient, and we're going to use that to displace the field. So let's do a volume sample, and we're going to sample the density field. And let's connect the first. Let me actually turn off manual. Yeah. So let's say I'm interested in the density, and then we want the point position, and we want to normalize this guy because it's a vector. We want to use it as a normal, and I'm going to multiply the point position with this. Let's add that. And let's add a multiply constant here, and let's take a look at this volume and see what we get. Cool, so the displacement is working. Let's do a visualization node and look at this in all its glory. 1024, and let's set the density to 10. Cool, so you can see it's working, and let's dive inside. Let's reduce this. And voila, we're adding details to this. Let's set it to the 0. Let's increase this back to see the details more. I think the noise is, yeah, it's probably too small. Sorry, we're not adding the noise yet. We're just pushing the volume, and the direction of this is actually, we have to negate this vector. Sorry. So let's negate this guy. Okay, and let's reduce this. Let me add this. I actually not so sure now. I'm gonna add the gradient to the point position, and let's turn off the caching, this for a second. Okay, let's add this. Let's use that as a sample. this guy. Okay, cool. Let's try 0. Okay, and let's turn off the negate. So it crashed. I'm gonna pause quickly and reopen this. Okay, cool. So back, and let's set this to 1. Okay, that's too much. Set this to 0.1. And let me disable the negate. I think we were pushing along the right direction. Okay, so you can see now we're pushing the volume outward along its normals. Cool. So what we can do is we want to take this noise here and multiply this result by the noise. Okay, let me delete that. And let's add a multiply. Okay, and let's turn on back the cooking. Try 100. It's too much. Try 10. You can see now the frequency is too, the details are too big. So let's try 0.25. And let's go back up and view this with all its details. And it's very important to always display this at full resolution because it's hard to see them if you don't have proper display. You have to always do a render to preview this. So let's try 0.1. Cool. So yeah, I think it's working. And the idea now is if we run this, which is what I used for this preview, I just played with the noise a little bit more. The gradient is going to update every frame. The noise pattern is going to update as well based on the input. And then we're going to be displacing the volume outward every frame. And this is just an illustration of what we're going to be doing in DOPS. In DOPS, there is another behavior that is going to add a lot more interesting behavior to the sim, and we'll talk about that in the next video. Thank you guys for watching, and see you in the next one. Bye-bye.